Good afternoon, ladies and gentlemen. Today we are looking at a prototype device that uses a ST microelectronics demonstration board. One of those classic LCD modules where you send it a set of instructions to get your stuff to be displayed or move cursors. And a cute little bunch of knobs. I'm using 2 of them. It came pre-built. It has 2 functions. You can push in to clicky them, or you can rotate them with the little click action. They're like opto. I think they're opto, but whatever this device sent a cleaned up signal to my microcontroller to interpret whether they're going forward or backwards, or whether it's getting the click signal. Now, the way I did this, I gotta see if I remember. So I'm gonna turn this knob up. So that knob's pretty obvious. Turning that knob will change your the number. Oh, looks like it changed some of the other numbers too. Alright, now let me click it. Oh, my clicker doesn't seem to work very good anymore. It's got a grain of rice behind it or something. Oh, there we go. And doesn't seem to do anything, so I must not have programmed anything for clicking that one in. Alright, let's try this other one and see what it does. Alright, so that's advancing. That's obvious enough. It's advancing within the number. Alright, let's try the second knob. So once I go to a new number, alright, so that makes sense. The other knob will then change the number. And you can move it to the next number and change it. Go back and move around within the number. So how do you get out of that number and go to some other variable? Of course, you can see I made up some names that may have made sense at the time, but of course you can always change that in your little program. Alright, so I'll give away the secret. I'm going to press this one again when they push it in, and oh, look at that. It then allows me to go to a mode where you're hopping to different numbers. And then I will press it again. And okay, you're within the number now. You can park it yourself at a certain digit and then go to the second knob and change the number. So there you go. This is a way to enter a number into your little computer, and then from there you can use those parameters, the numbers you chose, to do something. Control the machine in a certain way or what have you. This is only a prototype of a data entry portion of a project. Thanks for watching. Oh, programming the ST is for me it's a big pain, because they constantly have thousands of different microcontrollers and microcontroller demonstration boards, and in the beginning it was easy. They just had a few, but now you got to figure out how to choose the right one, start writing your program, which makes me really want to just give it all up and go back to those Arduinos, which I've never learned yet, but I heard they're very good, easy to use, and other such boards. The only advantage I thought of this at the time was it was a speed demon. The specs on this are just outrageously fast for a little micro board. Alright, anything else I can say? Okay, I'm using a breadboard to connect one thing or another. I made some notes on here. So the I/O on these boards, you can see they're brought out to some pins. You can kind of read them. All right, PE5, PD. So DC, those are like common sense. Port C. What do you got over here? Port C, Port A. They're either 8 or 16-bit ports or some portion thereof. So I'm just use some old computer connectors to get some wiring from this board over to my breadboard, which then I can then go and hook to this cable, nicely rainbow colored, you know, the resistor color code colors, and they're tied in some way to here, and then the program sends some I/O outputs to control and set up this little LCD module, which comes with, these have been around since I was in the 90s, 80s, 89, or let's say 90s, 80s, late 80s, at least the 1990s. And they haven't changed much in terms of how you communicate with them. And these are always fun. The maker of this, let's see if we can get some IDs on that. Sure Electronics, as seen upside down. You can write your computer program to all right, here's how it looks like they're giving some instructions. Upside down, of course. So they send signals like whether you're turning it clockwise or counterclockwise, whether you push the button, and whether a bit has passed, you know, like a train of bits probably, as you turn the knob. Anyhow, the program interprets that instead of the old-fashioned 2 wires coming from those opto knobs. Usually they're optically encoder knobs. I'm not sure if that's just resistor encoded or they got the fancy optical, but resistor ones will just wear out a little bit faster. Alright, I think I better shut up for now, and thank you for watching.